Stanford. Welcome to our session. We're going to look at sampling and estimation. But before we go any further, we need to appreciate the concepts behind each of these. To start with, a sample is simply a small unit that represents a bigger population. So a small unit is called a sample. The whole population is called a census. So a subset, in fact, is what we call a sample. The whole population, which is a sampling frame, is what we call a census. So time and again, people would rather go for a sample than the whole census for the following reasons. Number one, a sample is representative of the whole population. It is sufficient to give a premise or an inference pertaining to the whole population. A sample can also be time conscious. It may be done in a short period of time because of time constraints. The other thing is financial constraint. You may not have enough money to do or conduct a research in the whole population. So you would rather limit to your resources. So when you're doing your research, you'll do a case study of a particular region or segment. The universe size, no matter how much time and money you may have, sometimes it's almost impossible to really find out how much or how many babies are born in a day because of the universe size. Then accuracy level. Sometimes it's more accurate to use a small sample than a whole population. That is why sampling is done. Now, estimation on the other hand, let me ask, what is an estimate? What is an estimate? If I meant to ask. This is one of the key topics that has differentiated statisticians from just theorists. What's an estimate?
I can try.
Yes, you can try.
Maybe not the actual figure, but something close.
Exactly, simply a rough calculation of the value, a rough number or quantity or extent of something. It's a rough judgment of something. And so we may not be 100% sure of a certain premise, but we need to be within a certain range. It is like a projection, like Bright has put it, of something that you need to intend to achieve. Excellent. So Mariako Kumushi, where people will give you very wrong estimation. You ask how far a place is, they say, Paul, but you need to travel miles and miles. So estimation is very important so that you are within a certain confidence interval. So when you're dealing with estimation, we're dealing with confidence interval. So confidence interval is simply given by the mean plus minus the error. If I asked you to say, how long does it take you to drive to school from work or from home? You said 30 minutes. Or we can say plus minus Plus minus 5. If you're early, you'll be there in how many minutes? 25 minutes. If you're late, you'll be there in how many minutes? 35 minutes. Otherwise, your average time is 30. So this is what we call the lower class boundary, and this is what is called the upper boundary. Okay, so to translate this one backwards, the mean is simply given by lower boundary plus upper boundary divided by what? Divided by 2. And the error is going to be found by lower boundary minus upper boundary divided by 2. So let's use this to verify that. Are we going to find the mean if we add the lower boundary plus the upper boundary divided by 2? So what is 25 plus 35 divided by 2? 60 divided by 2, which gives us 30 as our mean. Is that so? If we want to find the error term or the level of precision, this term comes in the word within. When you see the word within, just know that we're talking about error. So let's see, you can start with the lower bound or upper bound minus the lower bound, you get the same figure. So that 5 minus 25 divided by 2, which gives you 10 divided by 2. What we get is 5. You can get a negative or a positive depending on which one you start with. So this is what we call the error term. This is what we call the level of precision. So under sampling, you will always be asked to calculate the sample size. For the sample size, the formula we're going to be using will be z squared variance over error. Or if you're given the proportions, we're going to use z squared pq over error. Then under estimation, so today I just want to meet on these 4 formulas. I'll teach you a song that I want you to memorize, because this is the song that you use when you'll be dealing with one of the key topics, which is called hypothesis testing. We're going to have the mean plus minus the z is a two-tailed standard deviation over n, or the confidence interval will be given by proportion plus minus z pq over n. And we square with that. So I have sent you a table that you're going to refer to. Now, the sum that I wanted you to take note of is some of these tables here. So we have what we call a confidence level. We have 4 common confidence levels. All confidence levels are above 50. We have 99, 98, 95, and 90. The difference from 100 is called the significance level. So what is the significance level at 99%? 1%. What is the significance level at 98%? The difference is 2%. And here the difference is 5%. And finally, the difference here is what? 10%. This is the difference from 100. So now, if we're going to get our alpha value, the alpha value is simply when you divide the level of significance over what? Over 100. So here we're going to have 0.01. And here we're going to have what? 0.02. And this is 0.05. And 0.10. So when we go to our Z value that I want you to take note of. So at 99%, we have 2.58. At 98%, we have 2.33. At 95%, we have 1.96. 90%, we have 1.645. So this is what I want you to master for now. So we'll be dealing with a two-tailed test for now onwards. So I repeat, we have what we call the confidence level and the significance level. So I want you to, for a short while, Within 2 minutes, just memorize this table, then I'll get back to you. Okay, so let's go through the table again. We said we have a confidence level, significance level, our alpha, and our Z. So we have 4 levels of confidence. Which are they? Number 1, what is the level of confidence?
99.
99.
Okay, we have 99%, then
98.
98%, then
95,
95, then
90,
90. What's the level of significance at 99%?
1%,
Difference from 1%. Then here,
2%,
2%. And here,
5%,
5%. And finally here,
10%.
10%. Good. Alpha is when we divide this by 100. So what is our alpha level here?
0.01,
0.01. Then here,
0.02,
and here,
0.05,
and here,
0.10.
0.10. Now, how do we read this from the table? There is a way in which it is read by the table. So I can either give you the memory one so that you can be able to easily memorize it, because these are the common ones, or I'll give you the steps that are taken in getting to them. So you simply need to subtract 1 minus alpha over 2. 1 minus alpha over 2. So what you're supposed to do is 1 minus alpha over 2. Okay, that you read from inside the table. Let's try for 95%. So subtract 1. What is the alpha for 95%? Is 0.05.
0.05,
So 0.05 divided by 2, you get 0.025. Then we subtract it from 1. What are we getting? 0.975. So when we go inside the table, the Z table is what you use. This table. So you go inside the table, you check under 0.0975. You find the exact figure or the most close possible figure. Find it at 0.9750. So you simply add the number which is side. Here we have 1.9 and 0.06. That is how we find 1.96. That is where the Z is coming from. 1.96. So our Z is 1.96. 1.96. Okay, let's try 99% together. Step 1, what do we do? 1 minus
alpha,
over 2. So what is our alpha?
0.01,
0.02 divided by what? or 0.01.
Yeah.
Yes. Divided by what?
2.
2. So what we get? 1 minus 0.005. Then what do we have? When subtract 1 minus that, quickly
0.995.
0.995.
995.
Okay, so when you check inside the table here, you'll find it at the closest is this one here, 995, 0.9. So what is the reading at 0.9950? It is 2.58. So I'll teach this as I would be teaching the t distribution, but for now, I need you to memorize these figures because you know where they're coming from. 2.58, 2.33, and 1.645. All right. Now, the question will ask, for instance, let's find the missing.
Sorry, I have a question. Why is the last one written 1.645 and like just having 1.64?
Oh, okay.
For
That's a good
90.
question. So to calculate it to be 0.10 divided by 2. So here will be 1 minus 0.05. Then when we subtract 1 minus 0.05, what are we getting? 0.9500.
95.
So when you go to the table inside here, you'll find a dilemma because there'll be two numbers that will be close to 0.95. This one and this one. So to pick, in all fairness, you pick in between here, a 0.5 there. So 1.645. That's why we get 1.645. Yes. Is that clear? So that's why we get 1.645 here. Okay. So now we want to go to our computation for finding the missing figure. So find the value of what? N. So for instance, if we're given at A, you're given our standard deviation as 4, our alpha as 0.05, and our error is given as 2. So what formula are we going to use here? There are two formulas. There's formula 1 and formula 2. You need to know which formula to use based on the data that has been given. So formula 1 has what we call the variance. Formula 2 has what is called a proportion. So ideally, the formula that you use is determined by the data that has been given. So if you're given proportion as 20%, you're given your level of significance as 1%, and you're given your P, your error as 2%. So at A, what formula are we going to use? Formula 1. So the sample size is given by Z squared variance over the error. Okay. So what is our Z? At 0.05, what is our Z? This is the same as 5%. So what is the Z for 5%? Let's go through our sum. 99, then 98, then
95.
then 90. What is the Z for 99?
1%.
2
For the
point,
Z, 2.58.
okay. Then for 98%, what is the Z?
2.33.
And 95%,
1.9.
1.96.
1.96. So this is standard. If you're not given any percentage, you assume it's 95%. Then 90%, 1.5.
1.645.
Good. So this is called the confidence level. What is the significance level for this one? 99 or what? 1%.
%.
Or the alpha is 0.01. About this one, 98%, what is the level of significance? 2%.
2%.
Or 0.02. 95%, what is the level of significance?
5%.
Or 0.05. And here,
10%, sorry.
or 0.10. I need you to master this because this is what will save you. You're not given this, you need to know it. So at this point here, we're going to use 1.96 squared times standard deviation squared, which is 4 squared, times the error, which is 2 squared. Okay, and you find the answer, part A. Part B, Z squared, we're going to use what? Formula 2, because we're not given the standard deviation. Our Z part 2, what Z are we going to use at part 2? Coming from here, what is our Z here? What is our Z?
2.58.
2.58. Here, where is this 1.96 coming from? Because our alpha is what? 0.05, which is 95%. So you need to master that very, very well. I plead with you. So during this week, our task will simply be what? To master that song, because that is what is going to help us a lot. So here our proportion was 20%, meaning the difference is our Q. If our proportion is 20%, then our Q should be 80%. All right. What remains is simply the calculation from your calculator. Okay. What remains simply the calculation from your calculator. Any questions before I proceed? Okay. So let me look at, before I go to the pamphlet, let me look at estimation as well at that note, so that we can
See, for us,
see how the formulas will be given.
because we will not be teaching like in my case. Just
So
but
if, for instance, you're given the mean as 10, the standard deviation as 12, our n is 36, then you are asked to find the what? A 98% confidence interval. So we know that confidence interval is equal to what? The mean plus minus z standard deviation over square root of n. So our mean there has been given as 10. What is our z? Coming from 98%, what is our z from the song? What is our z? Anyone?
2.33.
2.33. And our standard deviation is what? 12, then square root of n, which is 36. So here we're going to have 10 plus minus 2.33, and 36 square root is 6 into 12, we get a 2. So when we multiply the 2 there, what do we get? 4.66. So we start with the lower bound. 10 minus 4.66, what do we get? And 10 plus 4.66. Ladies do the minus, guys do the plus. What is 10 It's 5.34. And the upper bound is 14.66. So in this case, you comment in terms of the confidence level. You say we are what? We are 98% confidence that the true mean will lie between 98% confident that the true mean lies between 5.34 and what? 14.66. Now I want you guys to lead me. Suppose we're given a mean of 20 and our n is 49 and our standard deviation is 21, and we're asked to find a 90% confidence interval. Okay, what's the formula for confidence interval, someone? Confidence interval is equal to what? Yes, mean plus minus what? Z standard deviation over square root of n. So let's substitute together. What is our mean?
20.
Our mean is 20. What is our Z? 1.645. Now standard deviation 21 over the square root of 49. So we're going to have 1.645. This is 7. 7 into that 1 is 3. And the rest you can calculate. So I'll send you another link. For now, on the group, I'll send you just some piece of work to do just within 10 minutes on what I have taught you only.